How does quantum mechanics create parallel universes? Imagine a world where every possible choice you make actually happens somewhere else. Sounds like science fiction, but quantum mechanics suggests this might be true. This idea is called the multiverse hypothesis, and it connects deeply with how we understand the universe's future and its fundamental laws. Quantum mechanics is the branch of physics that explains how tiny particles like electrons and photons behave. And like larger objects, these particles can exist in multiple states at once. This is called superposition. For example, a particle can be in two places at the same time until we measure it. When we observe the particle, its superposition seems to collapse into a single state. But some scientists think that, instead of collapsing, all possible outcomes continue to exist in separate realities. This idea is part of the many worlds interpretation of quantum mechanics. It suggests that every time a quantum event occurs with multiple possible results, the universe splits into different branches. Each branch represents one outcome, and these branches do not interact with each other. So, in one universe, you might have chosen to stay home, while in another, you went out. Both possibilities happen, but in different realities. The core of this theory is the wavefunction, a mathematical tool that describes all possible states of a quantum system. According to the many worlds view, the wavefunction never collapses. Instead, it keeps evolving according to Schrödinger's equation, which predicts how quantum systems change over time. When a quantum event with many outcomes happens, the wavefunction splits into multiple parts, each representing a different universe. These parts are independent and cannot communicate with each other. Quantum entanglement also plays a role. When particles become linked, their states depend on each other, no matter how far apart they are. This entanglement extends to the entire universe, creating a universal wavefunction that includes all these parallel worlds. Decoherence is the process that makes these worlds separate and classical, preventing interference between them. It's like how fog makes it impossible to see through to other worlds. Understanding this theory can influence how we think about the universe's future. It suggests that the cosmos might be a vast collection of parallel realities, each with its own history and future. While we cannot currently test these ideas directly, advances in quantum computing and cosmology might one day give us clues. For example, experiments with superposition and entanglement could reveal more about how these parallel universes might exist. This idea challenges our traditional view of reality, making us question whether our universe is the only one. It also opens up new questions about the nature of existence and the future of the universe. Although the multiverse hypothesis remains a theory, it is rooted in solid scientific principles and mathematical models. It shows how quantum mechanics could be the key to understanding a much larger and more complex universe than we ever imagined.